ลงไหมลงปุ๊บ
สุกัส
เฮ้ย
เขาได้ยินสุกัสกล
ก็
สุกัสกลดังลั่นห้องเลยอะ
จริงด้วย
จริง
แต่พี่บอกไม่บอกเดี๋ยวเพื่อนกูหลับแล้วเต็มอิ่มไปไหม
อะไรนี่
วันที่20 กรกฎาคมเดี๋ยวนะ20 กรกฎาคม
ไปดิไป
ไปไหนอ่ะ
ส่งให้มันในเฟซอะ
ส่งแล้วไปไหนลงทะเบียนเร็วๆไปฝึกไปอบรมยังไงที่2 เดือนครั้งอะลงเลยปะ
ลงเลย
ไปดิปะลงมาดีไหนอ่ะเราไม่สมัครยังไงวะอ๋อตอนเที่ยงนะ
แค่ยังยัง
อ๋อมันจัดวันพุธนี่
Read this question and tell
วัน
me
พุธ
which
ช่วงบ่ายหรือ
case,
เปล่า
which equation should we apply.
ตอนเที่ยง
วันเนี้ยตอนเที่ยงตั้งนาฬิกาปลุกก่อนยังไม่ได้ลงนี่เลยแบบลงทะเบียนอะนายกอะ
มันเพิ่งเปิดวันนี้เพื่อน
ลงยัง
ยัง
Read this question very carefully and tell me which case out of 4 should we apply.
ชี้ไหนเนี่ย
อันนี้เปิดในนี่
First case.
เดี๋
Okay?
ยว
Understand why? Surface temperature is given, right?
ดูกันนิด
So I will show you the solution in here. It's very easy actually. Nothing too complicated. You have 2 solutions, but you go for the alternative one. So this is the case 1 formula, right? This is the case 1 formula, and they are asking the distance, right? They are asking x. So you input everything here, everything is given, and you get the value of x.
E อะไรนะ E C F E
ER
They are asking the minimum depth which we should keep the water points to avoid the freezing. To avoid the freezing means the temperature at that depth should be 0. It should not be less than 0. Less than 0 is minus. Minus means it will start freezing. So we will keep 0. Okay? 0 minus 15, minus 10, minus 15. And this is value. The last topic of this chapter 4 is multi-dimensional. So first we started with lump system, that was also one dimension. Then we started with the transient heat conduction in plane wall, cylinder and sphere, that was also one dimension. Then we studied semi-infinite solid. Okay, these solids were infinite, right? But they were also one dimension. Now we have to study heat conduction in more than one dimension. Okay, so it can be 2 dimensions, 3 dimensions, but very easy. We found one technique. Okay, in by using we can study heat transfer in multi dimension. So we use this technique superposition. By using this technique, superposition, we can easily study heat transfer in more than one dimension. So using a superposition approach called the product solution, the one-dimension heat conduction solutions can also be used to construct solutions for some two-dimensional and even three-dimensional transient heat conduction, provided that all surfaces of the solid are subjected to convection to the same fluid at temperature. The same heat transfer coefficient H and the body involves no heat generation. So, okay. Alright. So you want to study heat transfer in two dimension. We have not studied that yet. Okay, we are only studying, up until now, we have only studied heat transfer by conduction in one dimension. Now, if you want to study heat transfer in two dimension, in X and Y, and let's say it's a shape like that, it's a short cylinder, right? So this short cylinder, you can assume it's made of a plain wall, this plain wall, and a long cylinder. Okay, you want to study heat transfer in two dimension. You can assume, you have given this shape. Okay, it's a short cylinder, but it's made of a plain wall plus a long cylinder, and you have to study heat transfer in this pink color region in two dimension, this dimension and this dimension, in this pink. Okay, what you can do is you can study heat transfer in plane wall, okay, this X direction, and then multiply it with heat transfer in a cylinder, and you just multiply, and this is how you can study heat transfer in two dimension. R is this, okay, X is this. So calculate separately heat transfer first in plane wall and heat transfer in infinite cylinder, in the cylinder, and then just multiply. So their product is a superposition technique, and this is how you can study heat transfer in now two dimension. So the product will be temperature in R direction, in X direction. Okay, small t is time. So this is how, very simple, you can study heat transfer in more than one dimension. If it's a three dimension, I will tell you how. So this is a table here. They have shown you some shapes, okay, which are normally heat transfer is studied in, and you can study the heat transfer in one dimension, two dimension, three dimension based on these shapes. You can just multiply. Okay, so let's say the first one is infinite cylinder. It's a cylinder, and you have to study the heat transfer in one dimension. So it's easy. R and T, right? R, T. Second is semi-infinite cylinder, right? Second is your semi-infinite cylinder. You have to study the heat transfer in X direction and R direction. So this is, we just finished. You can study it by first heat transfer in the only R direction and then X direction, and then just multiply them. This is semi-infinite. Okay, it's going infinitely. Okay, in X direction it is going infinitely. In R direction it is not infinite. Okay, then you have short cylinder. Short cylinder, it's not infinite, right? So short cylinder, you can study the like I just explained. Short cylinder is a mixture of a wall and a cylinder. So in the wall you take the X coordinate, in the cylinder you take the R coordinate, and just multiply them. Semi-infinite medium, any type of medium. Okay, one dimension, just X. Quarter is like you are in a corner, right, and you have two direction, X and Y. So you just study in X and Y, and then just multiply them. Corner region you have now three dimension. So how will you study three dimension? Simple, just study heat transfer in multiply. Okay. Okay, so same way you go through these shapes. Okay, not all are in your syllabus. They have just shown it, like, just for your, like, here you are studying, it's a rectangular parallelepiped. So heat transfer in x, y, and z direction. So parallelepiped, they will study heat transfer first in x wall, y wall, z wall, and just multiply. Okay. And okay, we have some numericals. We have one numerical only. Okay, but I will explain this as well. This is your, you are trying to study heat transfer. Okay, heat transfer rate. If they are asking you heat transfer rate in this type of a system, you just study. So the heat transfer is happening in two directions, right? First
Yeah,
in
nó
x,
học
second
YouTube.
in y, right? If you use this in x direction, in y direction, and then subtract, okay, what is extra, you will get the heat transfer in 2D, and this is in 3D. Okay, these are the formulas actually that you have to keep in mind. Okay, let's do one numeric. 4, 8.
คืออะไรหันอะไรวะ
So there are so many numericals in your book, at the back of your book, in your exercise, right? In your exam, I will give you whatever is mentioned in the slides. Whether I have solved it or not in the class, if it's in the slides, I can give you. If it's an assignment, if it's an example, anything. As long as it's in the slides, it can be in your exam. Okay? So solve everything, and you don't have to solve anything outside the slides. Okay? But solve examples, everything that is in the slides. Okay. A short brass cylinder. Diameter is 10 centimeter, height is 12 centimeter. Initially at a uniform temperature, the cylinder is now placed in atmospheric air. Okay. Heat transfer take place by convection with the heat transfer coefficient. This calculate temperature, the center of the cylinder, center top surface of the cylinder 15 minutes after the start of the cooling. one technique that we can do here is we can use Hessler chart directly. This will make the calculation very easy. We need this value for plane wall and this value for cylinder. This value. If you see, if I calculate this and this, I can have this, right? This is for plane wall, plane wall. So I can have this value from Hessler chart. Understand? This is the easier way. If I'm giving you this question in the Hessler chart, it means you have to calculate this. X-axis and the pink lines you can calculate from the question. Okay, so I will show you how. X-axis is 2 alpha t L square. Okay. In our cylinder, alpha is 17 is 900 L 11. This is 8.4. Y axis is 111, which is KHL, which is 60. So for the pink line, which is 30.6, and the x-axis, which is 8.48, the y-axis will be 4.3. You can check here. For cylinder, I will use the cylinder graph, not this graph, right? So we are calculating temperature in two dimension in a cylinder, short brass cylinder, which is made up of wall okay. This is R, this is X. Okay. First I'm calculating temperature here. So I will calculate the temperature of the plane wall. It's made of a plane wall. Okay. This and then the cylinder in R direction. I multiply these, I get two dimension temperature R and X. Okay. R and X is 0, 0 in the A part. Okay. I can use Hessler chart. This is the y-axis. When this is 0, right? I can use this graph, that graph. And this is when this is 0, I can use this graph for the cylinder, right? But in order to find the y-axis, I should have x-axis and the blue lines. the second part of this question is asking top surface, center of the top surface. So which graph should you think I should use? Huh? Plane wall and cylinder, but plane wall and cylinder have three graphs, right? Plane wall also has three graphs and cylinder also has three graphs. So which graph should I use? I cannot use the center graph because you see this is only when the temperature at the center is given. Or T infinity, Ti, T infinity, right? This should be given. 1 divided by pi is given, or tau is given, or at least two of them is given, and I can find the third quantity, right? So in the B part, they are asking center top. So what is that temperature? Which graph should I use? This one? This one, right? Because see, T is given, so I can find out T at any point, right? This is T0, sorry, this is T0, so this is center temperature, right? This is only T, and then you can write down the coordinate, right? You see x divided by L, x divided by is the length. So when this is asking center top, it becomes 1 divided by 1 equals to 1. Center top, right? Center top is the surface, right? So you use this graph. You barely use this graph because this graph is for heat transfer. How much heat has transferred? Q. Okay? But mostly you use these two graphs. This is, okay, I will write down.
ให้เห็นข่าวที่เขาบอกว่าคนสลับกับสลับตามไปนะก็
นี่ไงมีแบบขาเราอ่ะคอมเมนต์ก่อนสนใจค่ะแต่รออีก2 ปีเรียนจบ
ผมมีโคตรคันอะหนักเลย
ไม่อยากขัดยังไม่ได้
ไม่รู้จะจบหรือเปล่า
All write down this on the graphs. This y-axis here, when this is T0, is showing temperature at center. Okay? So you write down this temperature at center for this graph, right? When in the second graph, your second graph is temperature at specific position. This T, the coordinate is not given, right? So this graph shows temperature at specific position. This is temperature at center. Understand? T0 is given, right? Or T0 you have to find out. So anything related to center temperature, you will use this graph. Okay? If it is temperature at specific position is given or they are asking, you will use this graph. have any questions? So you have to do the assignment. This question, this chapter finished here, and yeah, this we solved in the